Okie dokie. So the next couple of lessons are going to focus on more climate and weather. And we're going to start out with the biggest impact on climate and weather and seasons and all of that, which is the sun. Seen here just trying to love us. So, solar radiation as it's coming in from the sun is known as insolation. Um, and it is our main source of energy for a lot of processes. For example, convection currents in both the atmosphere and to a lesser degree in also in the ocean as well, are driven by solar energy coming in. Solar energy, if you have learned anything about light, um, light is going to have multiple forms. There's visible light, etc. But there is also infrared, which is has a longer wavelength than visible light, and it can also carry heat energy. So the amount of insolation any particular spot on the Earth's surface gets is going to depend on the season that that area is experiencing, as well as the latitude where it's located. So you see this diagram right here, which is showing you when you have summer in the northern hemisphere versus summer in the winter hemisphere. One thing I want to point out is that you do have the most direct sunlight hitting the equator, which is going to receive maximum insolation throughout the year, and it's going to have approximately equal length day and night. So, approximately 12 hours daylight, 12 hours of darkness. There's some variation depending on how close to the equator you are, and it tends to generally have fairly constant temperatures because there aren't these seasonal variations in incoming solar radiation. Higher latitudes, if you'll notice, and this is any latitude farther from the equator. So remember, if we're looking at a diagram of the Earth, the equator is 0 degrees latitude, and each of the poles is 90 degrees latitude. So the higher latitudes would be further from the equator. They will experience summer when that part of the planet is tilted towards the sun. So notice that the Earth is tilted on its axis, which we're going to talk about later in the lesson. And whichever side is more directly facing the sun and getting more direct energy is going to be experiencing its summer. You may think, oh, well, we probably have summer when we're closer to the sun and winter when we're farther away from the sun. And actually, for the northern hemisphere, it's opposite. When we're in our summer, we're actually at our furthest point away from the sun because the Earth's orbit around the sun isn't a perfect circle. Instead, it's an oval. And then at the poles, during the summer, they can receive up to like 24 hours of sunlight a day where they just have constant sunlight for a short period of time. And then during the winter, they can receive no sunlight for 24 hours a day and have constant darkness. So, going back to this whole thing about angle of incidence or direct sunlight, that's going to affect the intensity of solar radiation coming in. So, notice here is a chunk of light that is coming in at the equator. Here is a chunk of light coming in of, the same kind of um, intensity of light in the same kind of volume of space, if you want to think of it, and it's coming in at a higher latitude. What I want you to notice is that the light that's coming in on the equator is going to be in the shape of a circle, but the light that is coming in at higher latitudes is going to be more spread out. You have the same amount of radiation coming in, and so the amount of energy that you're getting is going to depend on the area that's spread over. If the area it's spread over is bigger, you're going to have less intense sunlight. If the area it's spread over is smaller, you're going to have more intense sunlight. So notice that at higher latitudes, you're going to have the same amount of solar radiation, but it's spread over a wider area, so it's less intense, which means there's going to be less heat energy coming in. So the highest amount of solar radiation any place gets on the planet is generally at the equator, and it generally decreases as you move towards the poles. And that's just kind of seen by this what you're looking at here, which is these kind of colors of these squares represent the intensity of the light. So notice It's more concentrated at the equator. So let's talk about seasons. What causes summer versus what causes winter? Well, as I said, summer happens when a hemisphere is more directly tilted towards the sun, like you see in this diagram right here. Notice in this diagram, the northern hemisphere is receiving more direct sunlight. And the days tend to be longer in the summer as well, as I know you notice when it's light till like almost 9:30. I've actually been to Scotland before where it was light outside up until like 11:30 at night. It was a little disconcerting, but if you go to other areas, you'll just have mostly 12 hours of daylight, 12 hours of darkness. All of this culminates in what's called the summer solstice, which is at the height of summer. And for us in the northern hemisphere, it's usually around, I believe, like June 21st or 22nd. And that is the day that has the longest amount of daylight. So longest day, shortest night. Conversely, when it's winter in your hemisphere, you tend to receive more indirect sunlight and the days start getting shorter. So your sunlight is less intense and you get less hours of sunlight coming in. So during the winter, you'll notice the days get shorter and shorter. Um, I have been up to see my family in Chicago, where in the winter time it starts getting dark around 4:30 p.m. Whereas here in Dallas, we're a little farther south, we tend to have daylight until about 5:30 p.m. We eventually get to a point for the northern hemisphere, it's usually around like December 21st, 22nd, when you're going to have the shortest period of daylight and the longest night. And that is the winter solstice. You also have in between 2 days where you have an equal length of day and night, even if you're not at the equator. These are called the equinoxes, literally means equal night. And there are two of those. The vernal equinox happens in the spring, and the autumnal equinox happens in the fall. And just a note, remember, whatever season we're experiencing here in the northern hemisphere, the southern hemisphere is experiencing the opposite season. So right now we're in winter, and in the southern hemisphere, it is summer. So, what gives us seasons? Well, what really is responsible for us having seasons is the tilt of the Earth's axis. So, if you imagine a pole kind of stuck through the Earth, like what you see here, and then imagine that it's rotating around that pole, that is the Earth's axis. So, the Earth does two things, it rotates around its axis and it revolves around the sun. And it's making both of those motions at the exact same time. Now, the fact is, our axis does have a tilt. Um, it is not a 0-degree angle. If that happened, we wouldn't have any seasons. Instead, you'd have kind of more intense heat closer to the equator and farther from the equator. You'd be in kind of I guess, an autumn type situation to winter. If you go the other extreme and your axis is tilted at 90 degrees, like Uranus is, other planets in the solar system have different tilts, then you would just have one pole facing the sun. It would get the most direct sunlight, it would have the most heat, and the opposite pole would just be freezing cold. The tilt of our axis, though, is right now at about 23.4 degrees. It actually does change over time. It's got this kind of cyclical change that it does, but it seems to be a kind of ideal because it gives us the seasons that we have, which are kind of well adapted for which life is well adapted for. And so, because of this tilt, we have our warm summers and uh, hot summers in our case and our cold winters, but the extremes of temperature aren't so bad. And because of this tilt, we also have a difference in the length of daytime, a length of daylight that we're getting in any particular location on the Earth's surface. By the way, when your pole is facing the sun, that means your day is longer. So when the North Pole is facing the sun, Northern Hemisphere has longer days. When the South Pole is facing the sun, the Southern Hemisphere has longer days. All right, that is it for this lesson, and we got one more coming up that will be loaded later tonight.